All right. So first of all, thank you very much for inviting me. I will try to present, first of all, the challenges and the things that, and I don't know if this goes. All right, I don't know why. Okay, I'll leave it. And the things that we see in the enterprise world, Eric presented what happened in the Mayflower, and the previous speakers have presented as well from performance perspective and from the industry perspective. I'll try to give you more an overview on what enterprise AI solution means and the related patterns. And if the time will allow, I will try to provide you a demo on the platform we're going to present. So as an agenda, I will discuss about the data complexity, architecture design, the IBM approach to the data fabric, the Cloud Pack for Data architecture, one of our platforms for doing machine learning, and not only. And then a couple of things about why IBM Power 10, and then show some demo. So first of all, let's have a look on why, right? Why an enterprise AI platform will be different. So again, this is very important because when you do the research, when you do so research and development, or for example, you do typically things at the edge, the things are different from the architecture perspective, from the technology perspective. But as you want to go more on the enterprise level and you are processing a vast amount of data coming into the data center, the question is, you know, how those things they kind of look, right? So what we see, and I think it was previously said, we do the way we learn machine learning is via massive data that we ingest either for supervised learning, unsupervised learning, or semi-supervised learning. So that means that the current machine learning models, they are driven by the data, right? If you don't have the data, you cannot teach those models, you cannot train them. So this is very, very important to remember. So what we actually, we can see in this slide is that the underscore the significance of the data by highlighting those proof of points on the significance of the data in better performing organizations. So for example, 165% more likely to outperform the profitability, building your trust advantages, global C-suite studies, IBM Institute of Business Values. Another number, 163, as you can see here, more likely to outperform the revenue building from the Trust Advantage or IBM Global C-Suite studies. And if you look on the left side, what we see is that 70% of higher revenue generation per employee. This is generating when you have more data in organization, you really understand what's going on. Either you take decisions in a better way, or you prefer to shape your future actions, like we have seen, for example, in Mayflower, right, in the video that Eric mentioned. So again, the data is very important, and this is why we need to understand, first of all, this data we have, and we need to understand how we can access the data. So accessing the data is complex. This is not that easy, right? While the value of the data is understood, the slide here introduced the challenges of organizations are facing today in the enterprise world. And you can see here 68% of the enterprise data is not analyzed, right? So rethink data based on the Seagate Technology report. 80% proportion of the time is spent on data cleaning, integration, and preparation. 80%, right? It's not just a number, as you can see here on typically on blogs or something. It's something real. This is what our teams they really do. Not mentioning the time when you wait for agreements or for filling the forms, people to give you and provide you the access, and so on and so forth. 82% of the data quality is a barrier, obviously, to their integration in the companies. And I will mention here, whenever you go to companies, say, hey, do you have data? Oh, we have plenty of data. Can we train this model? Yeah, sure, no problem. But when you ask if data is labeled, then typically the answer which is coming is no. So therefore, that is a big challenge from that perspective. And last but not least, 82% of the enterprises are inhibited by the data silos. And this is really true as we see many business units that they have various initiatives, they have various systems where the data is collected and stored. It's very hard, first of all, to really be aware of that the existing of that data in the enterprise. And second is how you can really access that. So that is a big problem, even on a single enterprise company. So in a world where you may actually create the data on the edge, then send it to a specific cloud provider, working with a third-party provider that is using a different cloud and so on. It's complicated. This becomes complicated. The data access has become one of the most complicated things, not only from, let's say, from integration perspective as well, but from the governance perspective, right? So we see discovering of the data that the enterprise has or can create in various forms and in various places. We see actually processing of all your data in a specific location is challenging because of various regulations. And the data engineering is becoming as well complex. Try to imagine you can create a machine learning pipeline that resides on some data pipeline that is actually cleaning and pre-processing the data ready to make it available for training machine learning models. And in case something happens in that data pipeline, probably one of the servers is not answering anymore and so on. How you can actually are you aware of that your data pipeline is not working anymore? How you can alert someone to have a look and be proactive on all these things. And the same thing when you have multiple machine learning taking decisions in a chain, how you actually do that and based on what kind of data you can consume, not only for training, but as well for inference. So let's look a little bit on the what, all right? So if we go here, what we can see is that we typically tend today in the enterprise to bring the data from the previous systems we have created, but as well to immerse into a new kind of forms and solutions of sources of the data. And that does mean a pendulum swing to everything which is decentralized, right? This balance between what needs to be logically or physically decentralized and what needs to be centralized. And that goes to a concept called data fabric, which is an abstraction layer to share and use data across a hybrid cloud landscape. And the idea is to have, we can have multiple catalogs, but should be only one source of truth or for a global catalog where your data resides. And this needs a fabric approach to manage, govern, and use the data to balance agility, speed, and SLA, as well as trust, which means deep enforcement of the governance, security, and compliance when we consume such things. And why this is important, and especially when we're speaking about machine learning and deep learning, is because if you don't trust your data, you cannot trust the models you train. It's simple like that. And this is very important because even in the fact when you have data coming from the sensors, how do you know that the sensors you had from the data collected are really calibrated in that moment when they are streaming the data? Do you have the metadata associated? Do you have the default values of the sensors operating environments to understand if that data, you can trust that data to train something or to do inference? So those are very important things we need to be aware of, especially moving forward when we are looking to new times when the machine learning and deep learning will be highly regulated. And that's something we need, it's a concern when we are speaking about collecting the data and training those models. So what are the elements of the data fabric? We have a couple of them, which are highlighted here. First of all, it's the self-service. The self-service is when you really, as a user, or let's make it the user being a researcher or a data engineer, just go on a portal, you search through the metadata, some information, some type of the data, some specific categories of the data, and then in the catalog, you request access to that data. Someone will approve that automatically if the profile is not matching with default values to access that data, and then you have the data. You don't have to ask friends or in the company and so on to get that data, to understand if you are allowed to see all the fields in the data or not because of some regulation. The system has to do that for you. Second is the augmented knowledge, right? Which is an abstraction layer that provides a common business understanding of the data. And that is something that will really help not only the data scientists, but will help as well the business analysis, right? To understand the value of the data they have. The third one is the smart integration, which is a range of integration styles to extract, ingest, stream, virtualize the data, and transform it. And I'm going to speak a little bit more about this, in a moment. Then we have the multimodal data governance, security, and compliance, which means unified definition and enforcement of the data policies tied to the knowledge layer. Which means that if, for example, your data sources are coming from European Union, and you know that there is a GDPR law here where you need to, if there is a personal information, you need to obfuscate the information and so on and so forth. In the moment the data fabric recognizes the sources of the data and the specific geography and so on, you can apply security policies to enforce the rules in a particular geography or in a particular country without human intervention. That's something that will actually allow the data to be consumed much faster than it is today. And then the last one is unified lifecycle, which is more like an end-to-end lifecycle to compose, build, test, deploy, and manage the various aspects of the data and machine learning. I'm going to speak a little bit as well about this. So looking on the value of the data fabric, we can actually see a couple of things here coming from various reports. One of them is the Total Economical Impact Study commissioned by the IBM in February 2020, where the data fabric will actually represent 25 to 65% reduction in the ETL requests. Again, that's very important number. 50% reduction in time to deliver unified data to the users. It's massive, especially if you are in a competitive situation, you really want to train faster, and you need to find the best data and the best value for the data to find the proper models for you to train. Those are important things. How we want to do this? Again, IBM data fabric vision, it consists in a couple of things. So first of all, we have a layer called Watson Knowledge Catalog that deals with preparation of the data, organizing, data profiling, and preparation, obviously, policy-based governance, where everything should be defined there according to the enterprise rules, country or geo-specific rules. Then to build and train machine learning models, do machine learning experiments, and so on and so forth, we use a component called Watson Studio. This is from visualizing models, develop and train, management lifecycle. I'm going to demo this as well. And then we need another component to deploy and run those machine learning models that we create, as well as monitoring them. So for that, we use the Watson Machine Learning. That is a component specifically to take the models which are trained with the help of Auto AI or without Auto AI or whatever, to be deployed in a specific space, from where we can do model operations or MLOps and dynamic retraining based on some criteria that can be defined. But in the enterprise is not only this. For example, in the university, you may say, well, I don't need to probably check the biases always and monitor my models because I'm not doing that much inference. But in the enterprise, when you put your models in the production, you need to continue monitor them for business KPIs, for explainability, fairness, for data drifting, and always try to automate this optimization of those machine learning models in the production. And therefore, that is another pillar, the fourth one, on how we manage and operate. We trust those machine learning models. And alongside of all these things, all those four pillars, we want to have a life cycle, an automated way of flowing the data through the whole thing, from the training to the testing, validation, and then inference, and have that as a continuous practice. This is a very important aspect when we look from that perspective. So as an approach, we believe that for the data fabric, this can bring intelligent integration, unified governance, especially when you have multiple business units with many dependencies between them, with many policies and so on, and acknowledge insights that will enable self-service for easy and user data consumption for collaboration. So here are some things we have here just as a side comparison. So when you look from the business perspective as a user, having the access to a data fabric, you will actually gain faster and more accurate insights to the easiest access of the high quality data, right? You have ability to focus time on analyzing rather than finding and preparing data, right? We'll try to cut off the frustrating free full services that shopping experience, avoidance of the bias analysis, increase the compliance and security, obviously, and accelerate the time to value. While from the technical perspective, you will decrease the effort in maintaining the data quality because you may automate these things, you can put some policies in place, and that's something that can help on the consumption. You can reduce the infrastructure and the storage cost, obviously, because in that case, the data, you may not have so much data that you may replicate over and over and over again, for example, by using the data virtualization. Faster and simplified data delivery process, and improving regulatory and compliance. This can happen as an automated fashion. So let's look on some data fabric use cases. And here we look from the consumer and business processes on data governance, multi-cloud data integration, customer 360, MLOps, and trusted AI. So the first one on the data governance and privacy, we see some very important aspects like metadata and the governance layer of all the data analytics and AI initiatives. So for example, classifying the data in the enterprise is very important, because if you classify the data as confidential, internal, public data, and so on and so forth, then it's much easier that data should be consumed either for internal purposes or either for external purposes when you are working with the collaborators or third-party companies. And again, that is another thing you can actually deliver with the data fabric. Then we have the anonymization, right? So one of the biggest problems when you work on enterprise data is that even if you want to give that data to another business department, if you have personal information in the data, you need to anonymize that data for training and testing and validation. And therefore, that is a big problem, because not all the companies, they have this kind of capability to anonymize the data on the fly. And that is a painful process, because someone has to review the data, has to try to anonymize the data based on the things that they believe that should be anonymized and so on and so forth. So it's not that simple. Then we see the multi-cloud problem that we had it in the beginning, right? So when you actually look from that perspective, there are a lot of challenges. And those challenges are coming from the fact that data is spread across multiple sources. So how we can have a single view? And the data fabric is actually offering that single view by virtualizing the data from various places. So we'll prevent delays, disruption of the mission critical data through the data resiliency and easy access. And you can see on the right side here, the intent of data fabric is as well to support the full data operation lifecycle through a governance, quality, master data integration, and collaboration. And we have the third one, the customer 360. So this is more like a general term that provides a comprehensive view of the customers in the enterprise by integration data across domains, which is a very important view, right? So having a business outcome at place with the competitive needs, breaking down the data silos is with integrated view of the data for a specific entity. And that is actually giving you, from the business side, a better view of what's going on for a specific entity from multiple sources of the data in an automated fashion. Then we have probably the most important for in the context of today, the trust of the AI and the machine learning operation, where the idea of having such platform that will automate the machine learning from infusing the data through the delivering the models and do the inference, it's something on a great value. And that goes in the direction of the AI governance by using the transparency monitoring for each stage during the AI lifecycle from creation until delivery and production. And here we are trying to bring some capabilities coming from IBM research for monitoring the models, explainability, draft biases, fairness, and obviously the quality of the model over the time. So let's see some examples from some customers. Here there's an example from ING. There's a bank in Europe using data fabric, where they have some challenges, as you can see here on the left, on the very complex environment with many legacy and obviously modern capabilities, with various regulations that they had to comply their environments, especially in regards to the data, and as well with a lot of needs for getting insights from their data they had. So we deployed the data fabric, and they were pretty happy by having all these things together. They are tied it in a single platform. This is another important aspect. You may want to have a single platform, single architecture, data fabric architecture that can fulfill the data operation and the machine learning operation together. They cannot be decoupled. Here's another example of a global telecom provider. Similar thing, large amount of data, a lot of data duplication, issues in consuming the data from multiple sources, querying that data, and obviously productivity was not in line with what they were trying to achieve. And they deployed the data fabric based on the IBM technology. So as an adoption, we can see all those three pillars, from single use case to multiple organizations. So on a single use case, you can see here that typically we try to identify a use case in a particular enterprise, and then we try to understand if they have a catalog or not. If not, okay, you need to build a catalog of the data that you have by using the virtualization, the data virtualization layer, so you don't move the data. There are cases where, yeah, you need to move the data for some reasons, but in general, we are trying to just, virtualize the data without moving it from their sources, and connect the customer's data across disparate sources. And then we have things, for example, for multiple use cases where you try to combine different integration styles and stores. For example, we have data sitting in SQL, in Hadoop clusters, and so on and so forth. So in these particular cases, solutions become more complex, and obviously we can actually work with the customers to achieve a true data fabric implementation. So how this can be deployed? Obviously, in a hybrid world, you want to have a couple of options. First of all, to manage on-premise. There are still customers that, because of data sensitivity, they want to have this data fabric capability on-prem. There are customers that they can work with infrastructure as a service or platform as a service, so you can deploy the data fabric architecture in such way, and then fully manage. So you just consume software as a service from IBM Cloud, and you get access to the data fabric platform called Cloud Pak for Data. So let's look on the architecture here. So this is something that you see in all the enterprise today. So they have multiple data sources depending on the industry, ranging from machine and sensor data, image and video, content services, social data, internet data sets, commercial, third party, when, for example, they decide to buy, or they have partners that they are delivering data, for example, marketing departments, they're producing a lot of data, application-related data, systems of records, especially, and all these things that are representing a tremendous amount of sources of the data. Where from where you need to find a way to do the ingest and do the integration with such things, and then you need to analyze those things together, right? You need to bring them together and see, the value of them, and not the value of a single component, but the value of all those things together in a direction that the organization will want to go. And then when you have the data access, which is again another important aspect, how I'm accessing all this data. And if for training is very simple, when you have data in motion, things become more complex, and you need to have an analytics layer for that. And then how do you explore the data, right? So let's say you have a platform like that. You need to have a way where you can really explore, try to visualize the data, to get some insights, what kind of data should be for a specific use case or application. As you can see here, either new business models, compliance and fraud, security, or operational risk. And if you architect all these things, you want them to be delivered on a platform that can be, can support hybrid operation, either on cloud or on-prem. So we came with this Cloud Pak for Data. This is the reference architecture we have so far, where we are bringing all those data sources, and we have a couple of layers, like we mentioned, for connectivity. We can analyze the data based on the software. You can see here, we can even connect to external sources like Cloudera, Oracle, DB2, Mongo, Netezza, Teradata, and so on and so forth. The list is very, very long, by using data virtualization layer. So we can virtualize the data, and then you can identify the data on the platform. So it's much easier to to do the catalog in this way. So we don't move the data will always be there where it has been created from the beginning. For analytics in motion, we use Apache Spark, and as you can see on the right side, we have a couple of components. One of them I was mentioning in the beginning is the Watson Knowledge Catalog for enterprise search, data catalog, and data refinery. We do have additional capabilities for data visualization, like Cognos dashboards, and Watson OpenScale, as previously mentioned, in machine learning for serving the machine learning models we train and monitoring them, as well as things like model inventory, data quality, governance, metadata enrichment. All those things are part of the platform. And they are great because when you bring all this together, you can say, well, that's kind of a simple approach, but when you try to implement them and deliver them on a platform that can really scale, is not that easy, and it's a challenge. And it took us a great amount of time to bring all these things at the enterprise level and enterprise capabilities, where such a solution, they have to really scale, they have to be designed, high available, and meet the customer requirements in terms of performance. All right, so let's ask ourselves why Power10, why this platform it should be considered as one of the best platforms for enterprise workloads, especially in the context of machine learning and deep learning. So as you can see here, there are three main things. One is relevancy, second, quantify value and differentiation. But what we can always highlight is that such platforms, not only that are reliable and they deal with a big amount of data, but on the same time, they are bringing always the most perfect solutions for the enterprise that can actually deal with computing where the data sits, right? So you can have various partitions on the system that can really be used for example, for analytics, can be used for saving the models, and some of them can use them for the system of records. So you can keep everything into a single system. What you can see here is the IBM Power Core innovation. So let's now look at some of this innovation on the Power10. Power10 servers can run a large number of models infused into a databases and application at scale, right? So in order to enable this, we doubled the memory bandwidth from main memory and the cache hierarchy. The level 2 cache capacity was also quadrupled to keep from the Power9 to keep the most of the working set in the memory, to speed up the computation, and obviously the key innovation that allows the Power10 core to execute machine learning efficiently is the set of the 4 MMAs or matrix math assist engines in each core. This allows the machine learning models to execute tensors or matrix computations very efficiently. We'll also add an accumulator to the MMA engine, so their temporary results do not have to be saved and retrieved from the main memory. And this helps almost 3 times or 6 times in reduction in the latency, which is one of the key factors of having low performance in inference. Another major feature of the MMA engine is the ability to process the data elements with the precision ranging from 64-bit to 16-bit and all the way down to the 4-bit. And this is important for models that can trade off lower precision for higher throughput, where obviously this is required. And for this, to sustain this, we have worked with OpenBlast and Eigen community to bring 16-bit precision math into the libraries. Power, it's currently, as far as I know, the only architecture that can support int4 precision. Most enterprise models support 20-bit precision, and for tabular data and emerging language and the vision models support 16-bit precision. It's really very powerful to sustain all these things together. And if we go forward and we can check something as well that we have do as an assessment for the pre-silicon engineering analysis of the Power10. We share our results here from running models on a different MMA precision levels on a DCM-based Power10 system, right? So those were previously published at the Hot Chips conference when running the ResNet 50 model on 32-bit, 60-bit, and 8-bit precision levels, comparing obviously with our baseline, which was the Power9 system. We had an increase in performance of 20x, which is tremendous if you think from this perspective, and that shows not only that we are collaborating with the industry to understand a little bit the needs which are in the enterprise, but as well we understand the implications of running such models on on a lower precision. And as you can see here, we do have support for bfloating 16 as well. Let's now look on how the MMA features will leverage by various libraries and frameworks will ensure that all the major frameworks, for example, PyTorch, TensorFlow, Onyx has been mentioned by Eric. Runtime can benefit on MMA. So PyTorch used OpenBlast and libutton, where we enable the MMA support. There are optimizations for 16-bit floating point, bfloating 16, obviously, and the support as well. It's available in Onyx as well. So this is something that IBM has today and can really export it. There's a research paper out there published, I think, a year ago. I added here if you want to go and search. There's a link where you can see the energy efficiency boosting in the AI-infused power and processor. And it's a very comprehensive research paper showing the performance of the Power 10 chip versus the Power 9 for FP32 computations and for int8 precision inference. So very great thing. I don't want to insist on this, but if you want to have a look more, just search it or just go to the link which is here. So in summarizing, here Power 10 delivers fastest business insights by running machine learning in place with 4 new MMA or matrix math assistance units in each core. And as mentioned as well by Eric, MMA provides an alternative to external accelerators and GPUs for execution of statistical machine learning and inference. That it aims to reduce the costs, not only in the power consumption, but as well the cost of overall solution, and leads to a great simplified solution stack for machine learning. So with that being said, Ganesha, I do have the time for a small demo. So an answer, I assume I do have time. So I will connect it right now to the Cloud Pack for Data, so I can share a couple of things here. Let me connect here to our system. Okay. Right, so now I'm connected to IBM Cloud Pack for Data. In general, when you are connected for the first time, we have options to create, as you can see here, data pipelines, build customer profiles, which map 360, or create your own catalogs, or search to the catalog, build machine learning models. I will show you the machine learning model part. So that goes to the projects. So let's say you want to see your existing project, or you want to create a project. I have already a couple of them here. I'll go to one of them, and the idea, the notion of the project is obviously in the enterprise, you want to collaborate with other data scientists. And each project has a couple of things, has assets, which means from the data access, if you, for example, if you virtualize the data, for example, that goes into a DB2 warehouse or in a SQL or whatever. You may have as well assets like typical, CSV files exported or imported into the platform. You may have assets like Jupyter notebooks and assets like models, right? So all these things, they come into a project. And then you may have as well another thing called jobs. You may schedule, for example, some particular jobs like a Jupyter notebook to be executed, or a chain of those Jupyter notebooks. You have an option here called manage, where you have things like access control to whom you give access. You can add collaborators in your organization. You can have options to modify the environments. By default, we provide some environments based on the system capacity and software stack, as you can see here, from X range number of virtual CPUs and gigabytes of memory, and depending on the software stack. But again, those can be customized. And we have as well some range of the integration third parties. For example, I connected to a Git hub, and that can be done on the system, so the data will be snipped very fast. Another thing that we have here, you can have always new assets that you can bring. For example, metadata import. I was mentioning new models you have, or you have created somewhere on another platform. You can create auto AI experiments, create dashboards for data visualization, and so on and so forth. I was mentioning exploring the data. For example, when you go to CSV file, you can very easy, you can go and explore those CSV files by visualizing and having the relative profile. So in this case, is a sample CSV file that show a couple of tables here, a couple of columns with the related values. You can easily go and do the visualization of the data. That always is very good to understand very fast the data before start exploring with the notebook. So you can have, for example, some multi-series. You can include, you can select some columns here, and you can have all these things together displayed. And it's a very fast analysis that anyone can do on a project when they're trying to explore the data, as well as the notebooks, right? So on the notebooks, you can always start a new notebook, or you can actually go and just run any notebook as a Jupyter notebook. That's not a problem. We do have the auto AI capability. This you can add it from here. I can give a name, for example, just give just a test, and then you can select the environment. Put here a test. And maybe I don't have it here created. Okay, I don't have deployed. Okay, I will try to take this like that. Yeah, I know it's not working. Oh, I didn't to associate a service, right? I'll go another time on that, but yeah, I'll go another time on this. So the idea is that you can bring all this together into a cooperation, as well as federated learning and pipelines and so on and so forth. And when you have all these things deployed, for example, here we have a trainer model, which is an sklearn created. You can have as well the input schema. So we keep all this information for this particular model, and you can deploy this model into a deployment space. Deployment space is based on what's in machine learning. In that particular case, you can choose your deployment space. And you can even give a name, for example, process name test, and then just promote this to the deployment space. That means that the model will be ready for scoring. The system will put this in the deployment space, and from there you have the option to wrap that machine learning model with an API. So that's something I think I have one deployed here, and the system will offer an API to an endpoint, and you can connect to this API and give some example of Python script, Scala, or Java that this model should be created. And from here, obviously, we can monitor the model and have all the things that we need on the platform. So yeah, that's typically what data science will do on this. But we have other options on the system. So we monitor the active runs, the failed, if there's something that we have. And obviously we can connect this to the another solution like OpenScale. to detect the biases and the data drifting over the time in case we have some concerns. And this is how we actually do this. The platform offers as well the governance, the catalog part. So you can see the catalogs, business terms, classification. You have the classified data. I don't have any rules right now here. You can bring in additional services onto the platform, like mentioned, OpenScale, Assist Watson Assistant, Discovery. So multiple things that can answer to multiple solutions on the enterprise. So with that being said, I'll stop sharing here, and Ganeshan.